Okay, now the second question here is a bit tricky. As you can see, this circuit, it already looks complex already. So wait, I'm missing a few things. Hold on. Okay, I was missing a few of the letters on the junctions here, which is okay. So question 9C. Calculate the current flows in each resistance of the following circuit in figure 3.2. 3. Figure 3.3. Okay. So as you can see, this is the diagram right here. So the first thing we gotta know is how to apply the Kirchoff's law. So how do you label the current flow in a diagram like this using Kirchoff's law? So we check the labeling of the battery right here. So since the negative is right here and positive is right there, we label the current is flowing in this direction, and that goes the same to all the other wires, which is this one. So the current flows in this direction, and this one the current flows in this direction. Okay, so now we know where the current flows. Now we have to check at the nodes, in which we have here is one at C and one at D. So nodes are the junction in a electrical circuit, which is simply as that. So this is one flow going in here, and checking at this wire, this is going this way, so the flow is going here. For this wire, it's going here, so it's going here. Same goes for this side. So you can take either junctions for the calculations. This will be also the same since the flow is right here. So it's this flow is right here, it's here, and so on. So be sure to label. So how do we label? Interestingly, is that we have to separate the circuits into sections of each independent wire. So this is battery number 1, battery number 2, battery number 3. So each of them have their own separate wires. That's the reason why I fold the paper. So this is 1 section, this is 2 sections, this is 3. So section number 1 is battery 1. So this is flow number 1. Current number 1 goes with current number 2, goes with current number 3. So same at the node. So current number 1 entering node C is the same as current number 2 exiting. That's the same as current number 3 exiting. Same goes to this one. So current number 1 exiting, and current number is equal to the current number 2 entering and current number 3 entering. So to put that into an equation, we can do it like this. So the first one we can do is equation at the junction. So we can choose which node we want. We can choose either C or D. It's exactly the same. So in my case, I'm going to choose C. So the summation of current going inward is the same as the current going outward. Okay, we can do that as I1 equals to I2 plus I3, because that's what's right here. This is equal to this and this total. So that will be our first equation. Our second equation would be the loop system. So that's why I do these 2 arrows right here. So the first loop is this one. So to check with that, meaning that I choose to do the flow this way. So for the formula of the loop, according to Kirchoff's law, which is the summation of the EMFs is equal to the summations of the IRs. How do we total them up together is that if they go against the flow, we minus them, but if they go with the flow, we plus them. So since we know that the flow is going from here to here, which is from negative to positive, or on positive go all the way around and then goes back to negative, so it goes this way. So meaning to say that on the flow that I choose, the EMF number 1 should be positive. So therefore it's E1 plus with E2, because E2 is also going in this direction, which is from positive and all the way back to negative. So it's also E2 positive, and those are all the EMFs. So we're gonna do the IRs then. So the IR is R number 1, and since we are going with the flow of the current, so the current shall be positive, which is positive I1 with R1, and then it's also positive right here. Ignore the arrow first. Okay, so plus I2 times with R2. So we substitute everything right here, and if we simplify that, that would be 23 equals to 2I1 plus 0.7 I2. So this would be our finalized equation. Second equation, okay? For the third equation, we use the same thing. We use the second loop right here, but we use the same concept as the first one. Okay, so the summation of all the EMFs. So since we choose this flow, I choose this flow, so it will be a positive E3 because E3 goes with the flow as well. So E3 is positive, while E2 is negative because the flow of E2 is this way. So since we choose the flow this way, it is a negative E2. So negative E2. And then we just substitute everything else as the IR. Now the IR, I3 and R3 will be positive because I3 goes with the flow that we choose. So it's plus I3 R3. But it's a negative R2. I mean negative I2 because I2 is moving in this direction, but our flow is this direction. So therefore, it's negative I2 R2. So we substitute everything from here. So this will be our third and finalized equation. Okay, now that we have all the equations, now we can substitute everything into another equation. So what I would choose is that I would try to make an equation or substitute an equation that has all of the same unknowns. So if we look at equation number 2 and equation number 3, we both have I2. So that will be the first value that we're going to be looking for, which makes things a lot easier. And in order to do that, we have to sort the equation so that this would be the unknown, meaning that the other term should be the subject. So therefore, if you can rewrite I1 as 23 minus 0.7 I2, and the second equation right here. So this is just rearrangement with the equation right there. So therefore now we have I2 as subject for both equations. Now we can substitute in the first equation easily. So the first one is, since I1 equals to I2 plus I3, so I1 is 23 minus 0.7 times I2 divided by 2 equals to I2 plus 7 plus 0.7 I2 divided by 0.2. So now we simplify it by removing the denominator. So I would just remove the denominator by multiplying the other terms with the number below it to remove it. So 23 minus 0.7 I2. I multiply this with 0.2. And then I2 is multiplied by both of the denominators, like here. And the last bit is multiplied with 2. So now we have this, a linear equation with everything else in here. So we continue as normal from here. Okay, so if you've done everything correctly, you should get the value of I2, which is equal to negative 4.85 ampere. Now keep the sign of negative right here. It will be very crucial for us to go through the rest of the calculations. So since we already know the value of I2, we can then calculate the value of I1 and I3 based on these equations. You can choose either one to do. So I1 is equal to 23. Substituting the value of that, negative 4.85. Put it back to. So I1 should get a positive 13.2 ampere, and if we substitute the value into the equation of I3, we would get the value of I3, which is 18.03 ampere. Thanks. You note that you can also substitute the value into the very first equation just to make things easier, and if you do so, you should get the exact same answer as the one right here.